Okay, so this is part 2 of 5-5, and again, we're just picking up with example 5 here. This looks really similar to things that we've done before. What we can do, and if you wanted to do a U substitution, you could, but you don't have to here. I can get 1 on the other side, and I can divide by 4. And I can take the square root of both sides now. Remember, when we take the square root of both sides, we have our plus or minus here. So I have sine x equals plus or minus 1/2. Well, that means I'm going to have a few answers here. I'm looking where sine x equals 1/2 and where sine x equals negative 1/2. Okay. And so that's going to be at x equals pi over 6, x equals 5 pi over 6, and then x equals 7 pi over 6, and x equals 11 pi over 6. And it's just from 0 to 2 pi. There's no coefficient on my x, so that's where I finish. Okay. I'm going to move on to number 6. Now this one looks a little bit scarier because we have multiple trig functions in here. That's okay. We can work with multiple trig functions, but there's a really big mistake that I always see students do here. What they do is they divide by tangent x on both sides. We can't do that because if we did, we would be eliminating some of our answers. And I'll explain that a little bit more when we finish this problem. What I am going to do is I'm going to subtract this on the other side so that it's set equal to 0. So that's gone. We have 0 equals tan x times sine squared x minus 3 tan x. I'm going to factor out a tangent x. And now this is factored. So I can set both my factors equal to 0. So I have tangent x equals 0 and sine squared x equals, sine squared x equals 3. Square rooting that, sine x equals plus or minus root 3. Now let's talk about this one first. Root 3 is greater than 1. But remember, sine just goes back and forth between 1 and negative 1. It never reaches something this big. So what that means is there's no solutions from this factor because sine x is never bigger than 1. Okay. Now, this one, we are going to get solutions. And so tangent equals 0 at x equals 0. And because we're going all the way to 2 pi, it also equals it at pi. Now, if in the very beginning I had divided by tangent on both sides, I would have missed out on these solutions. I wouldn't have gotten them because tangent would have been gone. And so what you might have said is that there were no solutions, but that's not true. There are 2 solutions here. Let's go ahead and move on to the next page. We have 2 cosine squared plus 3 sine squared equals 0. And again, we have something where we have 2 different trig functions. And so I have cosine squared, and there actually should be an x on here. So I'm going to go ahead and add that. Now, I can replace this with something so that I just have sines. I know that cosine squared x is equal to 1 minus sine squared x. Okay, so we have 2, and I'll replace that with 1 minus sine squared x plus 3 sine x equals 0. I can distribute everything in here, and I have 2 minus 2 sine squared x plus 3 sine x equals 0. And now this looks like something that I'm used to working with. I'm going to put things in a different order. So we have, actually I'm going to do this in one step here. I don't want to work with a negative out front, so I'm going to get rid of that negative. I'm going to divide by -1 and put this term first. So we have 2 sine squared x minus 3 sine x minus 2. So again, I divided by a negative and reordered my terms here. And so what I'm going to do now is use a u substitution. And so what we're going to do now is factoring. You can use whatever method you want for factoring. And so we have, when we factor that, we have 2u plus 1 and u minus 2 equals 0. So u equals negative 1/2, excuse me, and u equals 2. Well, remember, u, we didn't write it down here, but I replaced sine x with u. So what we really have is sine x equals negative 1/2 and sine x equals 2. Well, right away we can cross this one out because the same reason we just saw, sine x is never greater than 1 or less than -1. So that one's not going to give us any solutions. No solutions from there. You know what, from this factor? And that's because there are solutions, but just not from this factor. Now, sine x equals negative 1/2, and that happens at x equals 7 pi over 6 and at x equals 11 pi over 6. And we're talking about just from 0 to 2 pi. So that's our solution. Let's move on to the next one. This one is a little bit tougher too because, again, we have two different trig functions, but we do have an identity we can use for this. Now, remember, the double angle for cosine, we have all these different choices here of what we can use. And I'm going to choose this one because I already have a sine in the equation, and I don't have any other trig functions if I replace this one with just a sine one. So I'm going to replace this with 1 minus 2 sine squared x plus 3 sine x minus 2 equals 0. And now we can reorder things. I can do, and then I'm also going to divide by a negative again. So we'll get 2 sine squared x and then minus 3 sine x. And negative 2 and positive 1 is negative 1, but we divided by a negative, so plus 1 equals 0. And now we can use a u substitution. But I'm going to do this without a u substitution. If you're starting to feel like, okay, I can see it without the u substitution, you can do this without it. So we have 2 sine x minus 1, and we have sine x minus 1. So we have sine x equals 1/2 and sine x equals 1. This happens at x equals pi over 6 and x equals 5 pi over 6. This happens at pi over 2. So those are my solutions. Okay. I'm going to move on to the next page now. We have a few more examples here. We have sine x equals 1, or sine x cosine x equals 1/2. And that almost looks like the cosine double angle, or the sine double angle. So what I can do is I can multiply by 2 on both sides, and I can use my double angle formula. Okay. All right, so we have 2 sine x cosine x equals 1. So sine 2x equals 1. So 2x equals, that happens at pi over 2. But because I had that coefficient on there, I need to do the plus 2 pi n. and then I'll divide by 2 or multiply by 1/2. And I have x equals pi over 4 plus pi n. So let's do n equals 0, n equals 1, n equals 2. And plugging those in, I have x equals pi over 4 plus 0 times pi. And that's just going to be pi over 4. And then here I have x equals pi over 4 plus 1 times pi. Well, that's just plus pi, so that'll be 5 pi over 4. And here it's going to be too big. So x equals pi over 4 plus 2 times pi. Well, adding 2 pi to something is already going to be bigger than 2 pi. So this is too big. And that means my answers are x equals pi over 4 and x equals 5 pi over 4. Okay. All right, so this next problem takes kind of a long time, and so I'm going to come back to it in part 3 of this video.